I'm Kate Kelsch.
And I'm Elian Zacher.
Our project is the steppable piano. We made it using the circuit from the electrical engineering project Lab 5, and we replaced the buttons from that circle with FSRs, force-sensitive resistors. Our motivation was to combine what we learned from both labs. So what we learned from the acoustic lab was that it's really hard to get that to sound in pitch and make clean noise, but it's really fun to interact with. And then from the EE lab, our project, we learned that you can get a lot of notes that sound really clean and they're really easy to play with, but that lab wasn't super fun for a lot of people to interact with. So we wanted to make something that was fun for people to play with and really easy for them to make good music out of.
Yeah, so I think our initial thought was to create a game. So we made this really big piano that we can kind of step on and play with, and we wanted to create like a piano hero type game. Sadly, we couldn't figure out how to make a processing that worked with our design, with our electrical engineering design, nor could we implement different things that were already accessible via apps and so on to interact with our circuit. So what we decided to do is kind of combine what we had from the EE project, that we kind of had a looper combined with our circuit, and then we kind of could layer over a lot of different sounds over it and make it sound really, really cool. So what we tried doing is we made the 12-bar blues kind of bass going with it, and then after that we kind of created a pentatonic scale over it, and as you can see in the video, we were kind of dancing over it and relaying over it and trying to kind of interact with the circuit as a group and play with the circuit as a group.
Mm-hmm. And it was really fun to jump around, and we were also just improvising the whole thing, so it was fun.
Yeah.
So the structure of our steppable piano is we used the circuit from Lab 6, and then the buttons are placed with FSRs. Each one of those long wires leads down to the FSR. Each FSR is soldered and hot glued and taped. We really didn't want those connections getting loose. And then they're covered with a wooden plank that we painted in the makerspace. In addition, I had put the FSRs on these foam pieces to elevate them because we were worried about accidentally wearing them out if they were against the hard wood. But in doing so, we also had to add pads to the top and bottom. And then also through trial and error, we figured out that we also had to add pads to the side to make sure that when we stepped on it, it wouldn't just immediately tear up the hot glue. And that is the structure of basically each key on this board.
So for our final composition and game, we had two circuits. This is one of the circuits. It's a pretty basic circuit, one of the circuits we done in lab, but instead of having buttons, as Kay described, we have FSRs. And those FSRs are basically force-sensitive resistors, meaning when you step on them, they decrease their resistance, enabling the current flow from the positive to our different Arduino pins. And then with our code, what we did is whenever we had a voltage in one of the pins, we produced a different MIDI output. That MIDI output goes into the VCV rack that we built especially for this to make our board sound really good. Our second circuit is this circuit where we have different buttons. Our buttons correlate to modulation, volume control, and then controlling the looper. For this circuit, what we did is we combined the 4 modulation and volume controllers to the first Arduino, and what we did is we then generated different integer values when this is pressed and there's a voltage rise coming into the Arduino pin. This pin translates into the code, and that code correlates to increasing the amplitude of the MIDI output and or the frequency of the MIDI output, which then correlates respectively to volume change and frequency change. As for the looper, we have a separate MIDI output that again connects to our VCV rack, and that VCV rack sees this pulse coming from the voltage controller, and then correlated from the Arduino to just a classic MIDI output. Doesn't even matter what volume or what frequency it's in. And then what it does is it instigates the looper effect in the VCV rack to start the recording, and then when you press it again, it starts the recording.